Good day, sir. My name is CHAO, Matric ID MA17127. With my teammate Wei Junxing MA17098 and Chonghai Guan MA17134. Today we will start our audio presentation about BMM3531 Engineering Thermodynamic Lab Air Conditioning. So I will start my introduction. Air conditioning process helps to maintain a living space or an industrial facility and a desired temperature or humidity. So air conditioning processes including like simple heating, simple cooling, humidifying, and dehumidifying. As you can see for the right hand side figure above, they are showing the air conditioning process. So a useful tool for study and analyzing thermodynamic properties of moist air is the physiochromatic chart. So our purpose of this experiment is to practically show the use of the physiochromatic chart and thermodynamically analyze some of the air conditioning process. So from this chart can be used to predict changes in the environment when the amount of heat or moisture in the air changes. We can determine we can determine with the physiochromatic chart the volume flow rate. So in the right hand side figure below is our physiochromatic chart. So it displays the properties of air like dry bulb temperature, vertical line there. Below there, as you can see, there are a label with dry bulb temperature. After that, wet bulb temperature is a red color line, and the line is sloping gently downward to the right. And also our dew point temperature, there's our horizontal line in the figure, and relative humidity, the curve of the chart. So as you can see, the curve of the chart. Okay, so this chart, this physiochromatic chart help us to calculate and analyze the work and energy transfer of various air conditioning process. Basically, in this experiment, we have two objectives. First, to determine the coefficient of performance (COP) of air conditioner. Second, to analyze the relationship of fan speed and temperature in a refrigeration cycle. That's all for me. Thank you.
Okay, my name is Chonghai Chuan, MA17134. So, I am presenting the methodology in this experiment. So, before the experiment start, we might make sure the water tap is connected to the humidifier unit. So, after this, we can start the experiment. So the first step is the air conditioning unit was switched on. So and the radiator fan was adjusted to 0 speed for the first data collection. So the reading at the refrigerator pressure 1 and 2 and refrigerator temperature 1, 2, 3 and 4 and air humidity 1, 2, 3 and 4 and 5 and the air temperature 1, 2, 3, 4 and 5 and the flow meter are recorded. So all readings are taken within 30 minutes with 5 minutes apart. So repeat the step 3 and 4 for the ready fan speed at 20, 40, 60, 80 and 100. Okay, for the DEQ setting procedure, first measurement and automation explorer is selected in the desktop. So and click on the data neighborhood option and create a new task. So NIDAQMS task is selected in the selection of type of data neighborhood, and analog input is clicked under equisignal option. So, and next is voltage input in analog input is favored as it provides easier data interpretation, and physical channels which are numbered from AI1, 0, AI0, AI1, AI2, and AI3 are selected. A task name is provided to define the setting in DAISY-Lab. So the next is for one sample on demand is selected under type of acquisition mode which is available under the timing setting, and national instrument device is connected to the computer and the air conditioning unit in steady state, and run is clicked and wait approximately 10 seconds and the set safely. Okay, for the DAISY lab setting, analog input is selected from NIDAQMX under the input or output option from the module option, and create a new task with name as, and inside the measurement and instrument explorer. And another 4 channel is added to the measurement, which is channel 0 refrigerant pressure for PT1 and PT2, and channel 1 refrigerant temperature TT1, TT2, and TT3 and TT4. And for channel 2 is humidity, so and AH1, AH2, AH3, AH4, and AH5. And the last channel is channel 3, which is air temperature 81 under 85. So as the next is scaling icon is clicked, and the module is dragged to the worksheet. The number of channels are added regarding the number of the analog input. A digital meter module is included to display the obtained result of the experiment for calibration, and each channel is given a name according to the measurements, which is channel 0, which is ABS bar, channel 1 is refrigerant temperature, channel 2 humidity, and channel 3 is air temperature. So the next is the entire module is connected and run. The data is taken once the air conditioning unit reaches steady state and the result is obtained.
My name is Wei Junxin, ML17098. We will continue for the result part. For result, reading will be taken within 30 minutes with the interval of 5 minutes for fan speed at 0%, 20%, 40%, 60%, 80%, and also 100%. So the table below shows the result for fan speed at 0%. So our first objective is to determine the COP of the air conditioner. So data for refrigerator pressure and refrigerator temperature will be recorded from 5 to 30 minutes with 5 minutes interval. Then our second objective is to analyze the relationship of fan speed and temperature in a refrigeration cycle. Hence the data for humidity and air temperature and also flow rate will be recorded for the 30 minutes with 5 minutes interval. These two objectives will then be continued for fan speed at 20%, 40%, 60%, 80%, and also 100%. So for discussion, our first objective is to determine the COP of the air conditioner. Hence, the average refrigerator pressure PT and the refrigerator temperature TT from fan speed of 0% to 100% with recorded data of 30 minutes with interval of 5 minutes can be calculated by using the formula below, which the average refrigerator pressure is equal to the total refrigerator pressure from 5 minutes to 30 minutes divided by N, and the average refrigerator temperature is equal to the total refrigerator temperature from 5 minutes to 30 minutes divided by the N, where the N is equal to 6, which represents the 6 readings obtained from the 5 minutes, 10 minutes, 15 minutes, 20 minutes, 25 minutes, and also 30 minutes. Hence, the average PT1 at 0% fan speed from 5 to 30 minutes is equal to 3 bar, followed by the average PT2 at 0% fan speed from 5 to 30 minutes is equal to 7.89 bar, and also so on. Then the COP can be calculated which is equals to cold temperature divided by hot temperature minus cold temperature. For COP compressor can be determined from TT1 representing the cold temperature and TT2 representing the hot temperature. Then the COP condenser determined from TT2, which is the hot temperature, and the TT3 representing the cold temperature. Whereas for COP as the expansion valve can be determined from TT3, which is the hot temperature, and TT4 cold temperature. Lastly, for COP as the evaporator is determined from TT4, which is the cold temperature, and TT1 for the hot temperature. Hence, the compressor at 0% fan speed can be calculated from TT1 divided by TT2 minus with TT1 by referring to the average of refrigerator temperature in the table above to get the compressor COP at 0.611. So based on the COP calculation, the condenser has the highest average COP among all with 1.4095. Meanwhile, the expansion valve of air conditioner has lowest efficiency of COP with 0.4884. For objective 2, which is to analyze the relationship of fan speed and temperature in a refrigeration cycle. The average humidity AH, air temperature AT, and flow rate from fan speed 0% until 100% with recorded data of 30 minutes with interval of 5 minutes can be calculated by using the formula below, which the average humidity is equals to the total humidity divided by N. The average air temperature equals to the total air temperature divided by N, and the average flow rate is equals to the total flow rate divided by the N. So from the table below, it shows the AH1, AH5, AT1, and AT5. So this AH1, AH5, AT1, and AT5 represents the humidity and air temperature at sensor 1 and 5 respectively, in which the AH1 and AT1 are the initial humidity and air temperature, whereas for AH5 and AT5 is the final parameter at the outlet of air conditioner. Hence, the average AH1 for fan speed at 0% from 5 to 30 minutes is equals to 73.82, followed by the average of AH5 for fan speed at 0% from 5 to 30 minutes is 35.9, and so on. So after obtaining the AH1 and AH5 for different level of fan speed, the humidity difference and air temperature difference of each fan speed can be calculated for graph plotting. The humidity difference is calculated, which is AH5 minus with AH1, and same goes to air temperature difference with AT5 minus with AT1, and the calculated values is tabulated in the table below. The first graph shows the graph of humidity difference against fan speed. The humidity difference against fan speed shows a fluctuated trend where the humidity decreases when the air conditioner is used with the fan switched off. It is because slow-moving air spends longer time inside air conditioner and allows the dehumidification to be happen. When fan is switched on, the humidity increases. So the second graph, which is the graph of air temperature difference against fan speed, is plotted. Hence, the air temperature difference fluctuated with different fan speed with a peak at 20% fan speed, whereas the air temperature difference at 0% fan speed is the lowest. Since there is no linear trend that outlines the relationship of air temperature difference with fan speed, hence we can conclude that temperature is not significantly affected by fan speed. So in conclusion, the COP of each component varies with different fan speed with an average COP of 0.5261 in the compressor and also so on in the condenser, expansion valve, and also the evaporator. Hence, the variation in COP might be caused by the refrigerator temperature sensors error, which require to be calibrated. So when the air conditioner is used with 0% fan speed, the air stays longer time with the air conditioner. And other than that, although the second graph shows the temperature is not significantly affected by fan speed, but flowing air does help people to feel cooler with higher evaporation rate on skin surface. Hence, it is more important for air conditioner to work properly. That's all from our group. Thank you.